Okay, so now we're on composing types. So if we look at the description for composing types, so with TypeScript, you can create complex types by combining simple ones. There are two popular ways to do so with unions and with generics. So we look at them both in these next few videos. Firstly, we want to look at unions. So with a union, you can declare that a type could be one of many types. So for example, you can describe a Boolean type as being either true or false, which kind of is true, but a Boolean is going to be true or false. If we look at some examples below, you can see here a popular use case for union types is to describe the set of string or number literals that a value is allowed to be. So type window states could either be open or closed or minimized. So if you notice, there is a slight difference here with JavaScript. So the difference is that the OR operator in TypeScript is just one line, whereas JavaScript there are two. So that's a notable difference. What I want to do is I want to show you a better example of this. So if we go back into our VS Code, in lessons, create a new file called union.ps. Let's create a type. So before I do that, I'm going to create a variable. So the variable is going to be const my car. So my car is going to be equal to a string of BMW, and I want to define the type for my car now using the union type, because some occasions it might be that in my garage I have a few different cars, so my car could be multiple options. So let's go ahead and define the type. But first of all, let's just console log my car so we get rid of the error so we don't get confused. So the type is going to be type of my car, and what we could do is we could have the value of BMW, or it could be a Mercedes, or it could be an Audi. So what we need to do first of all is define my car here. So my car, the type is equal to my car, which is a union type, which means we could have multiple types in there. So essentially what it's doing is narrowing it down. So instead of passing in a string, we are passing in specific values in there. So these are specific makes of cars, and essentially my car could be either one of those three. So what if I was to change this to a new value? So say I've got a new car and this is Ford. And now we have an error saying that type Ford is not assignable to type my car. But the beauty of a union type is that it is extendable. So what we could do is do another OR pipe and then add the Ford value in here. So now you can see that is totally extendable. And also you can chain other types onto there. So what if I won the lottery and I decided to buy a few more cars, but this time they're going to be exotic cars? So I'm going to create a type called exotic cars or supercars or whatever you want to call it. And now this type has Ferrari, Lamborghini, and Porsche. So this might be a whole collection that I purchased, and we have a type for this. So what I could do is extend my car type on the end of here, added another OR pipe, and then instead we could do exotic car. So the type of exotic car. So what happens is we are adding an extra type in here, meaning that my car now, if I hover over it, it says type my car is equal to BMW, Mercedes, Audi, Ford, or exotic car. So now we don't need to look at this type, which essentially is Ferrari, Lamborghini, or Porsche. So if we revert it back to the variable that my car is added to, if we hover over my car, we now know that type my car is assignable to this variable. So now if I added the Lamborghini in here, you can see that it's added into my car here. So there's no errors showing up. If I was to remove the exotic car, now the exotic cars are taken away from my car garage. So what we need to do is put them back in, and then that will satisfy this type over here. So essentially union types enable you to extend your types. So it's open for extension but closed for modification. So again, you can add more types, so you can add Boolean, string, numbers, and so on. But in this case, it doesn't make sense to add numbers, so you can add the number 26 and then change this here to the number 26, like so. So now we've defined types on a single variable. What about on functions? So let's go ahead and do a function example. So what I'm going to do is I'm going to create a function, and this function is going to be called get toppings, because I like pizza. So what I'm going to do is I'm going to do an argument in here of pizza, and we need to define a type on pizza. So we'll define that. But also what we want to do is we want to just return pizza.toppings. So essentially in the pizza we have toppings, and that's what we need to return. So I'm going to invoke the function of get toppings, and what I want to do is pass in a variable of pizza or an object. So let's define the object, and this object is going to be a pepperoni pizza that I'm going to pass in as an argument. So pepperoni pizza, and I'm not going to give it a type for now. This pepperoni pizza is going to have a name of pepperoni. It's going to have the toppings, so pepperoni and cheese, and then it's also going to have a price of 15, and then you can decide what currency you want to put it in. But essentially this has a pepperoni pizza on there, it has a name, a toppings string of array, and also the price, which is a number. So what I want to do first of all is, instead of Typescript inferring the shape for me, what I want to do is define the type. So let's go ahead and define the type. So type of pizza is essentially equal to what I've just copied across from pepperoni pizza, which is the name is a string, the toppings is an array of strings. So the way you do that is you would do strings like so, and then array in here, and price is equal to numbers. So first thing I want to do is pepperoni pizza is of type pizza. So let's paste that in. And then if we hover over, it says it's assigned a value but never used, which again is telling me that there's an issue. We need to use the pepperoni pizza. So if I go in here, we have defined the pizza. It's receiving an argument of pizza. So it's type checking that whatever I pass in is going to be of type pizza. So let's pass in the pepperoni pizza into get toppings. And now you can see the errors have gone, which is how we want it. So function get toppings receives the pizza, which is the pepperoni pizza, and it will return pizza.toppings. And this is an array, so I essentially want the first index, and that's what we will do. So now, if I hover over get toppings, the function, the type says it's got an argument of pizza, and this is of type pizza, and then essentially it's going to return a string. But if we deleted this, this would show as an array of strings, as you can see here. So again, Typescript is inferring and it's helping you. It's helping you out in a sense where if you type check everything and you define your objects correctly, Typescript will also infer and help you out in that sense. So what if I wanted to pass in a value that is null or undefined? So let me do a new invocation here. So get toppings again, but this time what I want to pass in is null. So as you can see here, it's saying argument of type null is not assignable to type pizza. So how do we handle that? The way we would handle that is with union types, because this pizza could be another type. So essentially we would do or null, and then that way is saying that pizza.toppings is possibly null. So now what we can do is handle that in a different way. So first thing we could do is, if no pizza, return an empty array, or we could do return of no toppings. So that is one way to handle it. But what we can do is, if we go back into the Typescript documentation, so we've done the union types and we've done the function here, so you can add or and then chain on the next type that you want, so using union types again. But here we can do the use of the keyword type of. So essentially what happens is we can check the type of the variable coming in. So using the type of keyword, what we can do is handle it as well. So what I'm going to do is I'm going to invoke get toppings one more time. And this time what I'm going to do is pass in undefined. So now what we need to do is, it could be undefined as well. So we're using the union or operator to see that it's undefined. And we need to handle whether it is undefined. So if, and then we can do type of pizza is equal to undefined. You could return no toppings, or you could say received undefined, or however you want to handle it. But essentially what we are doing is we are using the type of operator from Typescript to say, if the type is undefined, then we can handle it in this way here. And these two ways are using guard clauses. So essentially we are handling it using defensive programming as well. And then finally, we should receive the return type as a string of an array in here. So if we hover over get toppings, you can see here, we hover over it. So pizza argument is of type pizza or null or undefined. And then the return type could either be a string or an array of strings. It could be the string of received undefined or no toppings. So as you can see, the union type is quite helpful in certain cases like this where we are receiving multiple arguments in a function. What we could also do is extract this, copy this out. We could create a new type equal to get topping just to make it a little cleaner and paste this in, which is the types. And then what we would do is replace all of this in here with the get topping. And now you can see it looks a little more cleaner. And essentially we are using what TypeScript suggests, which is we are handling the union types with functions and normal variables. And we are also using the keyword type of, which is quite handy in most cases where we want to check the type of something, and then we can handle it. And these are the ways we can use the type of keyword. So next, what we're going to be looking at is something called generics. And this one is quite difficult to understand, but I will make it quite easy for you.